Hello and welcome to week three's lecture. Last time around we talked about the different ways of making images using combinations of cyan, magenta, yellow, and black, the halftone pattern, screens, all that kind of stuff. This time around we're going to talk about the processes that are used to put those dots of ink on paper. So things like letterpress, flexography or flexo, gravure, offset lithography or just litho or offset, screen printing, digital printing, and we'll talk about some other things along the way too, possibly. So there's some terminology that's going to be useful here to understand some of the things that would go on, and I may mention these down the road, and if I do, but you don't have a definition, it makes sense. So I wanted to cover these right off the bat. These are important terms to just kind of be familiar with, have them in the back of your mind. So when we talk about relief images, we're talking about images that are created on a raised surface. To think back to your art classes, like a bas-relief engraving or sculpture or whatever, same kind of idea. You have an image that is created by making a raised surface on a plate or a imaging surface, whatever it may be, plate or otherwise. That surface is coated with ink, so the ink sticks to the raised surfaces of the material. Then the paper is brought into contact with that inked surface, and pressure is applied and the ink is transferred onto the paper. So we'll take a look at what that means and what it looks like a little bit later. But next one up is intaglio. This is a process that's virtually the opposite of relief. The ink goes into impressions or indentations or cells in the plate surface. So the surface area is cleaned off and there's no ink there. But the cells are filled with a thin ink, paper pressed against that fairly hard, and the ink is drawn out onto the paper from those cells. Lithography, there are no raised surfaces or indentations or anything. The plate is flat. It is chemically treated so that the image areas will accept greasy ink and reject the water. So lithography is, it operates on the basis of the oil and water repelling each other. And we'll take a look at how that works in a minute here too. But relief, intaglio, and lithography, those are the main key things to be aware of as we go along, because everything we're going to talk about, for the most part, falls into one of those three categories. All right, so I have put in a few GIFs. You can look up the YouTube video. There are links at the bottom if you can find that. The GIF that you're seeing on the screen here is just a guy setting up a simple letterpress job. Idea being that it's not terribly simple to do a letterpress job. It's not a fast automated process. It's labor intensive. You can see that each character needs to be chosen out of a set and arranged and then tightened into a frame. The area is inked up on with rollers and plates, and then see the rollers spreading the ink around there. This is one particular style of letterpress. There are other types that don't use this exact same thing. But you see that the paper gets pressed against those raised surfaces and the ink goes onto the page. Up at the top, you see just a very simple animation of the raised surfaces with the ink on it. And then the gray line is paper coming down in contact with that and the ink being transferred onto the paper. So the key things here is one that letterpress does not use halftones. The ink is spread out evenly over the entire raised surface of whatever you're using here. And so the result is that you cannot print for color stuff here very well at all. If you want colors, you just use that color of ink. You mix the ink themselves. It's very nice and high quality looking. If you've ever seen letterpress stuff, then it looks really nice. The quality is great. It puts tangible impressions into the paper. So it can be used for a lot of things like wedding invitations and whatnot. I'll show you some examples on the next slide. It is time consuming. It's expensive to set up and do. There are few places you can find to have letterpress done actually. And there are limitations. You can't print flimsy paper on it. It has to be high quality paper that will hold up to the pressure and the process. So you can see on the left-hand side some examples of letterpress, complicated letterpress, both cases. On the right-hand side, you see a letterpress job being set up with those individual pieces of type. That's a process that a lot of people used to be employed full-time doing that job, typesetting. They would take those keys and choose a font and insert them and arrange them and everything, and that's what a designer would do. Now we have InDesign. Okay, moving on. So flexography, or flexo, as it's referred to commonly, is another print technology. It uses a rubber or plastic image transfer material, or we'll call plate. I guess I should put plate on the definition slide earlier, but anyways, we'll take a look at it on the next slide a little bit more. But on the left-hand side, you see some of those thin films. These are non-porous materials, things that are used for wrapping and packaging, and those are commonly done with flexography. So on the right-hand side, you see kind of a cutaway diagram of what's going on inside of a flexo press. Starting at the very bottom, you have an ink tray. So there's a tray that holds a whole lot of ink, a fluid, and a roller that passes through that. It's called a fountain cylinder. It's just a cylinder that rolls through there, and the ink sticks to it, and that ink is transferred onto the analog cylinder. The doctor blade scrapes off the excess ink and then transfers that onto the flexible plate right over here. And you see these little indentations. This is relief printing, just like letterpress. The image is on the relief area of the plate cylinder, and so ink is going to stick to the substrate, the film or paper or whatever fabric that's being printed. The impression cylinder is there just to apply pressure onto the plate cylinder. The nice thing about this is it's not like lithography. It doesn't require a water-ink balance, and it can print on all sorts of different materials. So if you go to your grocery store and just look around at some of the packaging, a large percentage of it is done with a flexographic process. Okay, gravure. Up at the top, you can see that little GIF going. You see that the cells are filled with ink. The blue is the plate itself or cylinder, and the gray moving up and down is the paper or substrate coming in contact with that. So there are different types of gravure. I'm not going to get into it too much. There's photogravure, rotogravure. It can be done on cylinders. It can be done with plates. Money, U.S. currency, is printed with gravure on plates. The quality of gravure can be very, very high for a few reasons. In the reading material that you're going to look at, or videos, I should say, that you're going to watch this week, you'll see some interesting ways in the process and the work, the effort, and the expense that goes into creating gravure cylinders is immense. So it is an impressive result, but it's an expensive process to get there too. You can print a whole lot of stuff really fast with gravure. It's very consistent. It dries fast. You can use cheap papers or substrates. You don't have to have really expensive papers. Because of the difficulty of the process, it is difficult to imitate. So that's one reason why currency is printed using gravure. It's not economic for short runs. So if, let's say, you want to send out 500 flyers in the mail, definitely not the process that you're going to do. But if you want to do 2 million labels that are going to go on a package for a number of years, then that's definitely a good process for that. So on the right-hand side, you see an example of a finished gravure cylinder where the image is etched in there. If you were to look at that with a microscope, you'd see something like what's on the bottom. That is unfinished. It's just the copper, the exposed copper. It hasn't been coated yet. But the etched cells that are going to fill with ink. On the left-hand side, that's the process of it being etched with a device. On the top left-hand side, this little diagram here just gives kind of another example of what's going on from the side view, cutaway view. So there's an ink fountain at the bottom. The engraved cylinder goes right into that ink fountain, and then a doctor blade scrapes off all the excess ink so that the raised surfaces are clear of ink, and it's only the depressions or the cells that are filled with the fluid. As you can see over here, these engraved cells are filled and the surface area remains flat. As the substrate comes into contact with that engraved cylinder, the impression roller applies a whole lot of pressure onto that substrate, onto the engraved cylinder. which then draws out the ink out of those wells, those little cells, and it transfers onto the substrate and moves on. And that would be just one color per unit. So this would be our magenta, for example. You'd have another cylinder for cyan, another one for yellow, and so on. Okay, screen printing is another technology. If you look at the animation at the top, you see there's our screen, the blue line. There's our ink on top of that, and the substrate is the gray below that. As a blade comes and squeegees essentially the ink through the openings in that screen. It transfers ink to the paper or t-shirt or whatever material it is that you're screen printing. So it's a very simple technologically process for printing. It's not complex in what goes on. Basically, you have a silk screen, and your image is the screen. It's the holes in that material, and ink gets pressed or squished through that material onto your substrate. It's time consuming. It's labor intensive. It's difficult to reproduce for color work. So you get better results if you just mix up the exact color that you want to use. Take a look at t-shirts and things that are screen printed, and you won't see a whole ton of complex colors going on in there. If there are, then it's probably a different technology like dye sublimation. Here's just another example of the screen printing going on. This one's slightly more automated. You see the screen goes down, the squeegee comes across and presses the ink through the screen onto that poster material. Very nice results. Screen printing is very desirable, but again, it's kind of expensive because it's not fast. You have to do a lot of labor on each print, which adds up. On the right-hand side, you can see it being done by hand instead of by machine. There's a frame with a screen, and it's clamped down tightly, and then ink is squeegeed straight through that screen onto your substrate. Okay, so offset lithography. There are lots of different terms for this, but this is probably the most common type of printing processes out there. It's often referred to as just printing. This is what a commercial print does, is offset lithography. The picture that you're looking at is a sheet-fed offset press. We'll get into what that means here a little bit more in a minute, but you can see that there are pallets of sheets of paper. So that might give you a clue. Those sheets are drawn up off of those pallets and passed through the press. This particular press has 1, 2, 3, 4, 5, 6, 7 units, and each of those can supply a different color or coating or different material. So obviously cyan, magenta, yellow, and black. And then we can add in extra colors and things down the road or special coatings. But we'll get into that in a minute. Okay, so the base technology is what we're interested in here. With lithography, you have a flat plate. There's not a raised surface. There's not an indentation like we talked about before on that terminology slide. So what's going on is what you see in the graphic at the top, the little GIF. There is ink and water being transferred onto the plate. The ink sticks to the image areas because it's greasy, and the water, and it doesn't stick to the other areas that are wet. So that's important to this process. The bottom graphic might make a little more sense. So what you see here on the top, these are our ink cylinders, our rollers. They carry the ink from a fountain, which isn't displayed here. So imagine a big tray full of one color of ink, black in this case. These rollers just squish that around, spread it out evenly, and then press that onto the plate. And then this one down here is water. And so there's just a fountain full of water, and that transfers that onto the plate as well. And then down below, we've got a blanket cylinder, which is important here. This is why it's called offset printing. Our plate stays up here in this area. The offset blanket is where the image is transferred to. So just the ink goes onto the blanket, not the water. Not much of it anyway. Not as much of it anyways. That's an important key. Because what happens when you dump a whole bunch of water on your paper? It causes problems, right? So yes, your paper does get wet with this process, and that's one limitation that can cause problems. But the oil sticks to the blanket and then gets transferred onto the paper with this impression cylinder down below. And that paper passes on through either in sheets or in a web. So when we talk about sheet-fed offset press, it's just a sheet of paper going through one at a time. with web offset press. It's a web, so a continuous stream of paper off of a roll that gets cut up after the fact instead of cut into sheets before the printing. So the pros and cons, I guess, with lithography are: one, it's good at reproducing color images, continuously toned images with halftone screens. It does a really good job of that. This technology or process has been around for a very long time, and it's fast. It's easy to prepare the plates for it, but it does rely on those metal plates in order to print. You can use a wide range of papers and substrates, mostly just papers though. So you can't do crazy things with lithography like you can with some of the other things like screen printing. Because it's rotating those sheets through there or the web through there, it can go very fast and print at a high volume. There are occasional problems with the ink-water balance. Fiddling around to get that set up just right is difficult and leads to an increased make-ready time. So let's say that you're going to print 500 pages of some document or a flyer, then that's going to be difficult because it's going to take you a significant amount of sheets running through that press just to get everything up to speed, get the ink-water balance right, get the ink spread out evenly and reproducing correctly. You can also end up with problems because the paper gets too wet or because the ink is too dense, and so the pages will start to stick together and you end up with a really expensive brick of paper at the end. So here's just some more diagrams of how it's going. On the left-hand side, you see a little bit more detail than that little GIF that I was showing you before. There's an impression cylinder pressing the paper up against the blanket cylinder. Above that is the plate, and then the plate is getting its image from the ink rollers and the water rollers, and that mixture of ink and water being transferred to certain areas and not to others. On the right-hand side, you can see just a graphic of a close-up of what's going on inside of one unit of an offset press. Here's the plate above, and here's the blanket below. Digital printing, I had a difficult time finding good graphics, animations, or images to put in here and show you guys. I have some stuff I'll put on the next slide for you. But digital printing is the newest technology printing process of all of them, obviously. And there are some key players in the industry, HP, Xerox, and most of what they do is pretty proprietary. So they're not... it's a little bit more difficult to get a close-up view or diagram of exactly what's going on. But the basic idea is that you have a plate, or the equivalent of a plate, inside the press that is charged in certain areas using lasers, and then the ink or toner gets transferred using the principles of that electrostatic charge. So we'll look at that a little bit more. Let's take a look and see what's going on. Okay, so this is an excerpt from a marketing video from HP. You see that it doesn't hold a whole ton of paper, so it's not going to be used for certain types of print jobs. And then within here, what's going on? I want you to look right over here right now. So here's the lasers coming down from the top. They're imaging this, we'll call it a plate, that rotates around. And as the electric charge builds up, each of these units, it'll replay. We'll come back to it. I need to get a video that I can play and pause a little easier. All right. So our sheet comes up into the press. The lasers do their work up top. And then these little print units engage. And as each one of those engages one at a time, every time it goes around, it's adding a certain color, printing it on the paper, and then erasing that plate again. And then it adds the next color using the laser, and then it erases that color again and repeats the process over and over again. I'm going to let this play through one more time so you can see what's going on. But so if we're doing a 4-color print job, that sheet is going to go around 4 different times, one for each color. And you can see this image building up over here. I don't know what they have in this graphic going on where it loads a couple of sheets down before it spits anything out, but these kind of presses are capable of doing duplex printing, which means printing on both sides of the sheet. And you can also include more and more colors. Some of them have up to 7 colors available in the printer. So that'll do cyan, magenta, yellow, and black, as well as spot colors, Pantone colors, white ink, and different things, different coatings and things like that. Lastly, I just want to mention inkjet. Many of you are probably familiar with inkjet printing. It's used predominantly in desktop printers along with home laser jet printers and things like that. But an inkjet printer is basically a very precise and glorified can of spray paint. It's going to apply droplets of ink precisely at the very small size, 2 picoliters to 80 picoliters of ink, and it's going to spray those through nozzles onto the page. It doesn't have anything coming in contact with the page at all. There's no plate, no blanket, no impressions whatsoever. So there's a surface area of the substrate, and there's a distance between the nozzles. So it allows you to do some different things too. In some of our videos that you'll see later on in the class, you'll see some of those applications for inkjet are pretty interesting. It's used predominantly in large format, but there's also high-speed inkjet and new technologies coming out down the road too. All right, our next part of the lecture is going to look at some emerging print technologies that are coming out. One is there's a video, it's listed as optional in the reading assignment for this week. It's called nanography. Benny Landa is a pioneer in this and has patented everything. If you watch that video, there's some interesting stuff. It's a new way of applying ink to paper, and there's some definite possibilities for that to really take off and replace some older ink printing technologies, or at least to supplement them. Web to print is a term for, it's been around for as long as the web has, but it's not necessarily print technology, but it's just something to be aware of in the printing industry. When you go online to Shutterfly or Blurb or a company like that and you order a print, that's just web to print. It's not anything to do with how things are being printed or the process is being used. It's more an ordering technology. And we talked about that last week too, or in week 1, I should say. Lastly, large format inkjet or grand format. Those are just words for printing things really, really big. Typically, it is done with inkjet. If you're going to print really large stuff, then inkjet is the way to go because you can move those print nozzles across great distances. It's slow, but you can make some really large things. Large format is up to a certain size, I believe. It's 9 to 10 feet. Don't quote me on that. We don't do any grand format here at ASU, but that's really big prints. So usually that's done on rolls, and so it's end to end. So things like a banner or wallpaper or billboard, those are going to be done with larger format. This can be bus wraps and things like that. 3D printing is not so much a print technology at this point. Even though it has printing in the name, it's not really part of the print industry because it hasn't gotten to the stage of where it's manufacturing grade. Speed and reproduction of things that are used in commercial process are what's important to that being accepted or adopted by the print industry. Right now, the 3D printing that's out there is prototyping, and there are some definite uses for that. It's holding its own in terms of being a viable technology, but it's not going to fit into printing until it can come a little further. That said, there is a lot of science saying that it is going to go that direction. So keep an eye out. If 3D printing is something that you're interested in, we're going to have an option for you to do a little bit of research in this class. That may be something you look at, is how does that fit into the print industry and where's it going? There are other things tied to the print industry that aren't printing. QR codes, those annoying little things that nobody likes to use, but more so augmented reality. So augmented reality, or AR, is really something that's getting big in the print industry, at least in terms of print companies embracing the technology as a tool to reach customers. So I'll give you guys some demos later on in the class that you can hopefully download and try out some AR experiences from photographs of printed content and see how this can be applied. But if you guys have mobile phones now, there's all kinds of AR apps that you can download and try this stuff out too. Likely, most of you know more about augmented reality than I do. All right, web to print, we talked about that too. Not so much an emerging technology. Dye sublimation is moving along. There are more and more options at what it's capable to do. But the basis of dye sub is that you take a printed sheet of paper or solid ink, and then under heat, that transfers the ink onto a substrate. But it's not quite like iron on. It's a little bit more complex. The heat converts the solid ink or whatever into a gas. And so it actually sublimates into the substrate, like a t-shirt, for example. And so in that case, you have much more durability than just a vinyl layer on top of the material. Nanography, we talked about that a little bit more. Here's a graph. I'll let you guys go through them if you want to pause the video and read through this stuff. It's interesting, and I think there's a lot of potential there. But we're going to move on. I mentioned the advances in 3D printing, and this slide has some information in it. You won't be able to access these links, and I'm not going to go into them right now, but the PDF that you can download along with this lecture, the links will work, and you can take a look at some of these things. All right, here is the information. If you want to install this app and give it a try, here's one example of augmented reality being used on a printed product. It's hard to show the printed product in a video, in a PowerPoint. I'm going to let you guys try it out yourself. If you download this app, it's a free app, Zappar, Z-A-P-P-R-A-R. Find that on the App Store or the Play Store. And then all you have to do is open the app and point it at this cover of a magazine or whatever this document is. This little icon right there is like a QR code, essentially. It's going to trigger the app to start the augmented reality interaction. Now, this one is, I don't even remember what exactly it does particularly, but check it out. If you want to go to the company's website, Zappar, find them, Google them, and you can look through samples of their other material, and you can just point your phone at your computer screen and get the same effect. You don't have to have actual print samples. So it is kind of cool to take a person's business card and set it on your desk, point your phone at it, and all of a sudden it plays a video on the business card, or a tennis instructor jumps out and wants to play tennis with you on the top of your desk in augmented reality. So a lot of potential there, and this is where there's a lot of room for crossover between traditional printing and design technologies and industries with emerging technologies and industries like the augmented reality, programming, video game design, and other things like that. Lastly, I'm going to talk about printed electronics. So this is, again, there's potential for this to take off too, although it's been slower coming than what I had hoped based on things that I've been hearing over the last decade or so. Printed electronics are coming, definitely. There's a company local here in the Valley called Nth Degree, and they're in the process of producing printed LEDs, which is, you may not think about it, but it's a huge industry, the lighting industry. And if you could replace overhead fluorescent lights with just a wallpaper that emits light, that's going to save a lot of material costs, heat, energy, and ease of moving and changing up things. Graphics and billboards that have their own light built in instead of extra lighting shining on it is much more efficient in a lot of different ways. So there's a lot of potential there. It's a complicated thing, and there's a lot of hurdles to get that to market. But printed electronics, again, if you're interested in researching some emerging technologies, that's definitely one worth looking into.